morning, dear students. How are you today? I hope you're fine. Today we're going to have lesson 7, box plots. The median and interquartile range can be graphed using a box plot. A box plot is a graph used to summarize a distribution. A box plot is also called a box and whisker plot. The box plot shows the minimum value, lower quartile or Q1, the median, the upper quartile or Q3, and the maximum value of the data set. I have here sample box plot. Okay, this is a sample for the box plot. Minimum value here, lower quartile here, interquartile range, and this line is the median, upper quartile maximum value. The box shows the interquartile range, which is Q3 minus Q1. The line in the box shows the median, as I told you. The whiskers are the lines running from the box, okay, to maximum and to minimum, Let's see in example 1. A data set has the following values. This set of values is called the five number summary. So I have minimum value 15, lower quartile Q1 equals 30 as an example here, median equals 55, upper quartile Q3 equals 75, maximum value 100. Create a box for this data set. How to make a box plot here? Step 1, find the minimum, median, maximum of the data set. So find the minimum, median, maximum of the data set. Step 2, find the lower quartile Q1 and the upper quartile Q3. Draw a number line. Draw a box that goes from the lower quartile to the upper quartile. Here, as in the sample, can you see it now? Yes, as in the sample here. Draw a vertical line in the box at the value of the median. Here I draw a line. This is the median line. Okay, draw a line segment that connects the minimum value to the box and the other line segment that connects the maximum value to the box, as we see here, this line and this line to the maximum and this to the minimum. Okay, so the 5 values here needed for a box are given. Okay, here I put my data here in the box here in the box plot. Okay, 25% of the data here from the minimum value to the lower quartile. Here 25% of data from the lower quartile Q1 to the median, and another 25% of data from the median to the upper quartile, and 25% of the data, the last 25%, from the upper quartile Q3 to the value. And here it's given the minimum value given. Okay, in the example it's given 15, Q1 30. I'm just writing the values given to me. Median 55, Q3 75, maximum value here 100. Okay, moving to example 2. Use the data set 12, 14, 8, 12, 8, 19, 16, 12, and 10. Create a box plot for this data set. Reorder the data values from least to greatest. These are the steps. Reorder the data values from least to greatest. 8, and if the numbers are repeated, please write it down. 8, 8, 10, 12, 12, 12, 14, 16, 19, and I have here the median 12. Minimum value is 8. The 5 here summary. Okay, the minimum value 8. The lower quartile Q1 is the 9, and the median here 12. The upper quartile, after you calculated, you'll find this is 15, and the maximum value here 90. So drawing your box plot, here I have the lower value, the minimum value, 8, and here the lower quartile is 9 and then the median 12, the upper quartile 15, the maximum value 19. Okay, example 3. Don't forget to calculate Q3 and Q1. Calculate. Look at the box plot here. Look at the box plot given. Okay, how does the box plot shows variability? The lower and the upper quartile show the spread of data. Q3 is what? Q3 is, can you see, is 60. And we have Q1. Q1 here is 28. The IQR is 32. And as you know, the IQR is the, bravo, I can hear you, is the difference between Q3 and Q1. 60 minus 28 will give you the 32. Compare the box plot in example 2 with the one in example 3. Let's compare between this and this. The median speed for birds, here the median speed for birds is greater than the median speed for students. Okay, I have here the median speeds for birds and here the median speeds for students. So the median here is greater than the students. The maximum speed for birds, the maximum speed for birds is 70 miles. Here for the birds 70 miles and for the students 19 miles per hour. The range of the speed for students is, the range is what? Is 11 miles per hour. The IQR is 6, just 6 miles per hour. The range of the speeds of the birds 60 miles. Here the range is 60 miles. Okay, and here the IQR is 32. After calculating it, it's 32 miles per hour. The greater variability in the data on the speeds of different birds than there is for students. The greater IQR is, the greater the variability, the lesser the IQR, the more consistency there in the data set. The greater IQR means that you will have greater variability, greater in the differences. The less the IQR means that you will have more consistency in the data set, or it means less variability. Math around us. Do you know that the Kingdom of Saudi Arabia has more than 52.7 million mobile users? The number of information technology and internet users continues to grow rapidly. Okay, this was an information for you. The number of minutes, here I have an example. The number of minutes each person in a group used the internet this past weekend is shown in the box plot. Okay, I have here 0, 15, 45, 55, 72. What's the value of the interquartile range for these data? Do you remember the interquartile range? Yeah, it's the Q3 minus Q1. So I have here Q3 is 55 and Q1 is 15, and the difference between them, the IQR is Q3 minus Q1 equals 55 minus 15 equals 40. Okay, moving to step by step, construct the box plot and find the interquartile range for the data set. I have here data set 5 summary values. Minimum 15. Minimum, I put here the minimum. Remember, I draw here the line and draw the box and draw here 2 lines extending from the box. Don't forget. And this is the minimum value. This is the maximum value. Okay, okay. The minimum is given 15, so I'm writing here 15. Okay, okay. According to also here the numbers in the number line. And Q1 is 18. So Q1 here 18. I'll write here 18. Median 33. Don't forget this vertical line is the median 33 and Q3 is 45. Don't forget to write here Q3. and here the maximum value I have 80, so I write here 80. So the interquartile range is very easy now. Yes, the difference between Q3 and Q1, 45 minus 18, 27. Complete the 5-number summary. It's called the 5-number summary. Construct the box plot and find the interquartile range of the data set. This is how we find the question. Data set I have here 20, 18, 30, 39, 40, 26. Order the data set from the least to the greatest. So 18, 20, 26, 30, 39, and 40. Minimum here as you see 18. Q1 I have here Q1 is 20. Bravo. And the median here is 26. Okay. And then Q1 39, Q3 39, and the median here 40. So what should we do now? And don't forget this black here is given. The black writing here is given, and the pink is the required. So the minimum, I find the minimum is very easy, 18, and the Q1 is given to you in the question, 20. Median here 26, I get it. The median here I get it. How? By adding. Don't forget they are even, so just add 26 here again. 1 2 3 4 5 6. So I'm going to add 26 plus 30. So after this I take the maximum, which is here the maximum, the 40. Then interquartile range, I have the interquartile, do you remember? That's, yeah, the Q3 39 minus the Q1, this is 20. 39 minus 20 equal 19. Okay, here construct the box plot and find the interquartile range for each data set. Construct the box plot using a number line. I have here the 5 summary values given. Minimum 50, Q3 67, median 90, Q3 145, maximum 200. How can I plot this? I here have the number line and I just draw a box here, and the median here, the vertical line, and here I have the minimum, and here the maximum, and here Q1, and here Q3. And how to solve the interquartile range? Q3 minus Q1 will give you 78. Okay, easy now. Okay, here I have data set 48, 30, 36, 45, 56, 27, 30. Complete the 5-number summary. Constructs the box plot. Okay, the minimum here, where's the minimum? 27. And here the data set 5 summary values. The minimum, that's the 27. Here I reordered the numbers from the least to the greatest, 27, 30, 30, 36, 45, 48, and then 56. And draw here the box, the minimum 27, maximum 56. And here for Q3 I have 48, Q3, and Q1 30, and here the median here 36. Okay, the median here, the numbers here 1 2 3 4 5 6 7, so the number in between will be 36, the median. And the interquartile range is the difference between Q3 and Q1. What does the length of the box in the box plot represent? Here, this box, interquartile range. Moving to the problem solving, and Angela says the lower quartile can never have the same value of the minimum value in the data set. Is he correct? Prove your answer by creating a sample data set. Also construct a box plot for the data. Here I have the data. Okay, here I have, for example, the data set is 10, 10, 10, 20, 45, 50, 60. So I have here the median will be, I have 1, 2, 3, 4, 5, 6, 7. So the median will be 20. So I draw here the box and the median 20. So here the minimum value will be 10. And here the minimum value, like the first quartile, is 10. Has the lower quartile and the minimum value are both are 10. And here I have here quartile 3, and here the maximum value. Elena is examining two data sets. Data set 1, 45, 32, 48, 49, 45, 50, 52, 47, and 50. Data set 2 is represented by the box plot. Which data set has the greatest interquartile range? Explain. Data set 1, I want to reorder the numbers, the values here from the least to the greatest: 32, 45, 45, 47, 48, 49, 50, 50, 52. Then the data set here, I can the Q3 minus Q1. What is the Q3 here? First I find the median: 1, 2, 3, 4, 1, 2, 3, 4. So I will take the middle, it will be 48. Then this is the first and this is the second. Okay, the first, the lower, I do what? 32, 45, 45, 47. So I'm taking 45 plus 45, it will give me 90. 90 divided 2 equal 45. This is the lower, okay, the lower values. And then going to the upper values, here between 49 and 52, I'm taking 50 plus 50 equal 100 over 2 equal 50. So the difference between Q3 and Q1, 50 minus 45, it gives me 5. Data set 2, I have here 34 minus 32, it gives you 2. Data set number 1 has the greatest interquartile range, since 50 minus 45 is greater than 34 minus 32, 5 greater than 2. Now we have covered lesson 7. Let's go to lesson 8. Misleading graphs and statistics. Time to learn. Data displays can have shapes that suggest a certain conclusion. However, a closer look may show something very different. Examine example 1. Examine the two bar graphs below. Which graph is misleading and why? Graph 1 appears to have a greater variability in the length of bars. Can you see here? What do you notice about the vertical axis scale? Okay, graph 1 doesn't start at 0. Graph 1 doesn't start here at 0 for the vertical scale. Graph 1 is misleading because the scale makes the bars appears to vary more in height. Okay, so graph 2 is a better representation of the data set, as it begins here or starts with 0 and gives me good information. Okay, representing data correctly. Example 2. The line graph shows the sales in thousands of dollars for a store that recently opened. Explain why the graph is misleading. Suggest a way to make the graph more correct. Okay, notice that the vertical scale starts at 0 but does not use equal intervals. Notice that the vertical scale starts at 0 but does not use equal intervals. The line graph shows two turning points that appears small. Did sales really drop and then go up a small amount during 3 and 4? Here during 3 and 4. Okay, the points on the graph suggest that there was a small drop in sales between days 2 and 3, here between 2 and 3, and a small rise in sales between 3 and 4, and between 3 and 4 there is a small rise. However, there was a major drop and rise in sales. Sales went from 8,000 to sales went from 8,000 on one day, okay, on day 2, from day 2, okay, this is 8,000 as you see, to what? To 4,000 on day 3. okay, which is not reasonable. Do you know that more people travel to Italy, France, China, Spain, and United States than any other destinations? The travel industry was 65 billion in 2016. In this graph, misleading. How is it misleading? Okay, let's see. Can you see the graph here? Okay, it starts here with 40. Okay, the vertical axis starts at $40 billion instead of 0. This is the first thing. The order of the intervals and bars show descending years instead of increasing years. Okay, I have here I will enlarge this for you. I have here 2025, then 2020, then 2016, then 2014. So it can't be, and which make it appear that sales are decreasing when they are actually increasing. Step by step, the two graphs shows the annual snowfall for a mountain over 2 years. Which graph is misleading? Why? I have here these two graphs. I have here, it starts from 0, 4, 8, 12, 16, 20, 24, and here 14, 16, 18, 20, 22, 24, here 2001, 2002, 2001, 2002. The graph that is misleading, which graph? Graph 2. There is a break in the vertical here. Can you see? There is a break in the vertical axis scale between here 0 and 14. As you see here, from 0 and 14 we have here a break. This makes the bar for 2002, this makes the bar for 2002 appear much longer than the bar of 2001. Use the graph to answer problems 1 and 2. Is this graph misleading? If so, explain why. Age of internet users, and here the percent, and here the age. Okay, let's see. Possible answer what? Yes, the vertical axis starts with a scale of 20. Then goes here to a scale of 10. It begins with a scale of 20, then goes to a scale of 10 after 40. The horizontal scale intervals are not equal. As you see here, the horizontal scale are not equal. They are not equal because of the unequal intervals on both scales. There is a greater difference among internet users aged from 17 to 55 than what's shown in the histogram here. So there is also lesser difference between those aged 17 to 55 from those aged 55 to 65 here as shown. So this is misleading graph. How could you improve the graph? I can use a scale of 10 on the interval axis. I can use here a scale of 10. Use intervals of 10 of the edges beginning at 15 and ending at 65. So this may be an solution to make this not misleading, to improve the graph. Use the graph to answer problems 3 and 4. Explain how the graph is misleading here. The horizontal axis doesn't have equal intervals. We have here from 2001 to 2004, then 2013. So we don't have here equal intervals, which makes the increase of the number of wins between 2004 and 2004 and 2013 look greater than it actually is. What change would make the graph less misleading? How can we make it less misleading or not misleading? Rescale the horizontal axis. make the horizontal axis in a new scale to show equal increments of 5. Okay, I have here multiple choices. The bar graph compares the preference of two types of yogurt, brand A and brand B, favorite brand of yogurt, the frequency here. As you see, 5 more people preferred brand B than brand A. Okay, I have here 25 and here 30, so the right answer is the first answer, is the difference between them. Which statement explains how choosing an interval can affect the data values in a line graph? The interval should be the same as the median of the data. If the interval is too small, the data may not appear to vary. If the interval is 10, the data will always be easy to read. If the interval is too large, the data may not appear to vary. What do you think? Of course, the last one. If we have the interval is too large, here the data may not appear to vary. Okay, there will not be variation here. Okay, problem solving. Use the histogram for problem 1 and 2. The histogram shows the distance people live in a city. I have here number of people and here the distance in kilometers. Okay, as you see here, without looking here for the question, I have 0, 10, 10, 20, right? And 20 to 50 and 50 to 60. What happens here? Okay, what is the histogram misleading? The intervals are not equal. Intervals are missing. There are intervals missing. There should be an interval from 20 to 29, one from 30 to 39, and another from 40 to 49. If the data shown in the graph were graphed correctly, could you describe the shape of the data distribution? Explain. Okay, since how the data falls in the 3 intervals between 20 and 49 from here and here, okay, so is missing, it's difficult to say that the data distribution might be shaped. There could be a greater number of data values in the interval from 20 to 29, from this part to this part, for example, and few in the other 2 intervals, which would skew the graph to the left, okay? Or the data in the 3 intervals could be evenly distributed now, which would make the graph appear more symmetrical. Okay, here Jamil and Cora study the graph about computers. Cora claims that the vertical axis should be renumbered, so the scale increases by 20. Then the graph will show a large increase in computer usage from 1980 to 1990, and from 1990 to 2000, followed by a smaller increase. Okay, here, this one. So Jamil claims the vertical axis, the vertical axis of 50 as shown is okay. The graph will show the same large increase described by Cora. Which statement of them is correct? Both statements are correct. By estimating values shown on the graph here, the bars will be 25, 150, about 335, and about 360. 335 and 360. Okay, here. So the size of the increase will still show whether the vertical axis scale is 20 or 50. Okay. So remember that a good graph has a clear title, clearly labeled axes, and equal scale intervals and spacing. Again, a good graph has a clear title, clearly labeled axes, equal scale intervals and spacing, begins at 0 or has breaks, and has a scale sized to show changes in data. Otherwise, it's called misleading. The 2 graphs below do not communicate the same message. The second graph is misleading because the scale interval on the vertical axis is too large. Okay, to accurately show the changes over time. Okay, as we see here, from 100 to 150, from 150 to 200 and to 150. So I have here very large spaces, but here I have from 110 to 120, 120 to 130, only 10 the difference. So which is better? This one is better.